There we go. We should be recording now. Just to give a brief explanation of how this works. If at any point you want to if you have a question, or at any point I say something that doesn't make sense or you're confused on, please do not hesitate to cut me off and ask a question about it. The worst thing you can do is waiting until we're finished with everything and then ask a question, which even then I'm still fine with doing that. I just want to be able to kind of have the train of thought when we're on it. Second thing, if at any point you have something that you want to go over, like an idea for something to go over, you can put it in either the general chat or the NOMAC chat, whichever. I am recording this, so just keep that in mind. But aside from that, the couple of topics that we're going to try and start off with, we'll probably go, as Derp wanted, go into Git and GitHub. We'll do a little bit of Scrum and static analysis. We'll do some structural design patterns and generally just go over design patterns overall. And then a little bit of continuous integration, kind of how that actually is implemented, how that works, things like that. Yeah. As far as actual Git and GitHub, were you guys familiar with? What things are you kind of half on, and what things do you think you've got down pat?
I think most of the GitHub stuff's pretty familiar since we've been using it all semester. I don't know.
Fair.
But
okay. Derp, was there anything that you were thinking in specific for Git and GitHub? Like, for example, like merge conflicts or something? Or is it more or less just how Git itself works?
We can probably skip Git actually, because I just remembered I have a GUI that does most of that for me.
Fair. I will say
it's probably simple enough that, I mean, a lot of the commands are basically self-explanatory.
Yeah, and actually there's something that's I don't know if many people are familiar with, but I'm gonna pull up a different project. IntelliJ has built-in Git integration, but one of the nice things you can also do is with just normal Git terminal, let's say you forget a command like git merge, you do git help merge. And this will pull up a help page on the command, everything like that.
Also,
super
your
helpful.
IntelliJ looks really weird. Is that the new theme?
Yeah, it's the new theme.
Oh, I like it. That's pretty cool. Shit, I gotta try that.
Yeah, they can.
Icons in the left, yeah.
Is there old UI you can switch to classic as well? But there's some bugs with this, but I'm still getting used to it. But it functions, which is good.
Yeah, that's different. I like it.
Okay. Okay. Any other questions regarding Git? Or GitHub? Or actually, I guess it's better to just briefly talk about difference between Git and GitHub. You may already be aware of this, but Git is just a software. The way that software works is whenever you try and create a new project, it actually makes a new folder, and that folder is called .git.
by software, you mean it's a version control tool? Or?
Yes. So Git is the name of a version control tool software, and whenever you run the Git command, so whenever you have Git installed, your computer, you type in Git in a command line, it's going to go through your path variable, find the directory that has an executable named Git, and when you type in, for example, git init, it will take whatever. Actually, I just demonstrate this. Sure. Command line, PowerShell, sure. If you just do git init, you'll see it adds a .git folder, which is hidden by default. And you can see all the information it actually stores. You never really want to touch these unless you really have messed up something in your local version control, but even then, it's better just to repo in general. But anytime you do git add, git commit, you are basically storing data inside of this folder. No folder is actually, this is completely offline. Now GitHub is basically a service that hosts these files, and as a result displays them in a pretty format. So like when you upload your Git, when you do Git push, for example, you're going to push it to something called a remote, and a remote is just a URL that listens for certain Git kind of requests. So typically, if you ever go on GitHub and you look at code and you see this this link here, HTTPS, at the end of it, you always see .git. This is kind of like the how you can tell GitHub is just basically storing this folder, this Git folder, and then constructing the content of your actual project from this version control, if that makes sense. Any questions on this?
So is it only Git or GitHub that allows you to work with like having multiple users working with the same source code?
So Git is actually the one, you can technically copy and paste your Git folder to other places. The difference is now it's technically two different projects. So when you upload your Git folder to GitHub, you can then link this GitHub between multiple Git projects. So you add them as a remote in several places. So basically I can give this GitHub a repository to 5 people, and all 5 of those people can add that as a remote on their local Git folder, which I can probably do by just this git remote or help. So you do git remote add, and then there's an optional for a branch master name. So the name of it, let's call it GitHub, and then the URL is that. And then now if I do git pull GitHub, oh, this is a hidden, is it? Oh wait, wrong remote. There we go. And now if we actually check here, there. You see that? That kind of answer your question? Are you still confused on the difference between GitHub and Git?
Oh, it should be good.
Any other questions? I want to give that like 5 seconds before I switch. Alright, cool. Next on to Scrum. What were some of the, I guess, kind of, what were some of the overall process of Scrum is just that you kind of, you have specific roles for who's managing the actual meetings. So it's basically like your team lead to some extent. They're kind of keeping track of making sure everyone's operating at the right pace. So like making sure that development is happening every day, making sure that tasks aren't being left stale. At least from my understanding, that's kind of how it goes. Is there any kind of questions specifically about Scrum. I'm pretty sure everyone here had to do it, right? What's up, Nathaniel?
Scrum Master is normally separate from the team as well. It's normally someone outside of the team.
Oh, so is it normally like the
It's normally someone like on the ops side instead of like the dev side, but they're normally like their only job is to handle like the Scrum. But so it doesn't have to be someone on the team that's being the Scrum Master.
Okay, so is that like basically the person who's in charge of communicating with the client, or?
It depends on the company, but I think that was something she touched on when she first introduced the concept, was that they don't have to be a part of the actual team.
Okay.
And I think like the whole idea behind like Agile is like having that person be separate.
Yeah, which makes sense. So that way you're not actually you're not too involved in the process of having developed. There's more of, you can kind of take a step back and say, hey, where are we at with this? Do we need to move it to a different date? Do we need to kind of split up the tasks, I guess? I don't know.
Yep.
I'm assuming for her understanding the different roles, we're going to be going with the ones that we actually went over as this class, which is the Scrum Master and Git Master, which Git Master is basically the person who cleans up the repository and makes sure that unnecessary files aren't being committed, like the build folder or the .ds store, or the .idea folder or .class path, depending on your IDE. They're also the ones, I don't know if they're dedicated to dealing with PRs. I have a feeling that they just have to kind of review PRs to make sure that they're they don't have the information I just specified before. We want to go over anything else about Scrum? Anything else that was... I know I'm not touching on everything, I just want to make sure that we have time for everything.
Was there like a Scrum process that happened she talked about?
Here, let's go over what she has strictly. So this Scrum guy, okay, so this process I'm pretty sure is when she's referring to having a meeting to set up your actual user stories and your sprints, and dedicating the point values to user stories and kind of assigning tasks, and also on the flip side of that, when a sprint ends, kind of having a meeting there and making sure everything is wrapped up by that end. So like the process of also designating what the sprint's going to be about, what are the goal of that sprint, who's has what role in that sprint. So basically the kind of stuff we were doing in our deliverables. Do you remember that? Questions on that?
Yeah. No, I'm good.
Okay. We good for Scrum? Anything else?
Do you think you can post that review class.pdf in like the Discord? I can't find it on the canvas.
This one, I believe, is her last slide on here, which I can also post.
Okay, the week frequency. Okay.
There you go.
I didn't even realize I was there.
Yeah, so what we went over the last day of class was basically a review session, and therefore all the things that was on her slides should be under the slides and material. That's what I'm using as a reference. I didn't make this myself.
Oh, I see.
Oh yeah. Does everyone here know how to read a burn down chart?
Yeah, I think we got it probably.
Oh yeah. Awesome. Then...
You think, just make sure, can you actually go over it real quick? Because I want to make sure that I'm...
Yeah.
Like...
So the basic idea of a burn down chart is that if you have some level of effort, so some way to measure the effort you put into every sprint. So let's say you assign points to user stories in this case. If you take the maximum amount of effort points you have, so add up all the points in your user stories, and then spread that across the timeline of your sprint, there's a certain like velocity that they refer to as, or like a speed at which you should be removing points, or not removing, but rather completing user stories during that time frame. So ideally every day you should be kind of finishing tasks in a way that's that will lead you to eventually having no tasks left by the last day. So like a good sprint, typically you want to have this line stay kind of consecutive with this like projection. So the projection is always going to be linear. It's just going to be, well, in her examples, it's always going to be linear. You start at however maximum points you have, you end at 0. And so in theory, if you do work consistently every day, you should be roughly in line with that. But as students, we end up having dry spells, we end up having finals, we end up having a lot of other stuff. So we end up having these periods where it's just flatlined. And that just means that we haven't changed in point value, like no tasks have been completed in that time frame. And so usually what she's probably going to have on the actual final is saying, hey, given something like the top one here, we know this is a bad sprint. Now we don't necessarily know why. A burn down chart does not tell us why. It just tells us, hey, we weren't completing tasks at a fast enough rate. So one reason could be that we assigned too many tasks to one user story, and so that user story that has 40 points had like one task left by the end of the sprint or something. And so even though you're working on it the entire sprint, because all the tasks were not finished altogether, those points were never decreased, if that makes sense. Another thing could just be that you're not working consistently, which is a pretty common thing. Like if you don't work during the weekends, you're not going to see any progress there.
Big thing, velocity is how like much you're getting done at a certain time. So that's the slope of the green line. And then an ideal velocity is constant across the whole sprint. So like starting at the top, it would be no points done, and then at the bottom is everything done. And that's a constant velocity.
Yeah. And so like the red line here is the constant velocity. The actual is the one right here. So where you can see that changes, like a user story was completed between these two time dates, as well as from here to here, and from here to here. Everything else in between, there may have been progress change. Things may have been moved to in progress or moved to testing or things like that, but the only during these periods were all the tasks for a user story marked as completed. And that's the key factor with these burn down charts. So good planning means that your user story should have equally distributed points, not like not like forced, but like they shouldn't just be like one task or one user story has 50 points, the other one has 2. You want to have some distribution so that it's not so much work for one user story that it takes up the entire sprint.
Yeah, that makes sense. I think the only thing that I was confused about was the 2 different lines. I didn't know what that the second one was the ideal chart or whatever. But yeah, thank you.
Yeah, of course. Any other questions regarding Scrum, burn downs, anything like that?
What about reading the one in the bottom?
Reading the one on the bottom, this one is a little more ideal.
Not the graph, but like the one with all the user stories underneath it.
Oh yeah. So this is the one I believe generated with Melhaze's tool. The idea behind it is that kind of you can see a marker when like every row is a task. So you can see user story number 41, task number 79, and then the idea is that this is a kind of a timeline of the entire sprint. So anything that kind of breaches this dotted line on the right hand side is past the sprint deadline. Anything to the left of this dotted line is before the sprint starts. And the color theming is like, okay, if it's in red, it was new. So it was, you can kind of think of it as like this task here was never touched. It was created out of the sprint, but never touched. Here, not entirely sure why there's double lapping. I don't know entirely how to fully read hers, but from what I understand, the red kind of like highlighted boxes are saying this is the timeline where it was in progress. The yellow is the timeline of when it was in testing, and then the green is the timeline when it was marked as complete. That kind of makes sense?
Yeah, I can see that.
So you just want to look for even workload kind of between everybody, and that everyone is like stuff isn't staying in progress for too long of time. Like the third from the bottom, that one would be bad because it was started like at the beginning and wasn't finished until then.
Yeah, and not only that, it's it wasn't marked as in progress for more than a single day. It wasn't marked as testing for more than a single day. It was just marked as completed.
So what would be like the ideal one? Like the ones in the middle, kind of?
I think an ideal one would be something similar to this.
Gives other examples.
There's another example?
I think there are inside that document. Maybe they're just worse though.
Yeah, I think these are. Yeah, these are worse.
Like 42. 42 is better.
Yeah, the 42s.
One of the good ones. Yeah.
I'm trying to find 42.
Yeah,
it's like
initial list.
Kind of hard to point out, I guess.
The user story 42 or task 42?
US 42.
Is that on
Right
the
below where you
first
have
page?
circled.
Oh, okay.
They're right below the ones you circled.
Oh, here. Yeah. Where you can see they're in progress probably for like a day. Or they're marked as in progress for a day, they're marked as testing for maybe 2 days, and then they're marked as complete for the rest. And not only that, they were marked as in progress pretty quickly out of the start of the sprint. Here, somebody marked it as in progress, and then they're like, oh shoot, I don't know how to do this. Let me move that back after a day. And then somebody else is like, oh, okay, I'm gonna mark this as a progress again, but they never ended up putting into testing, they never completed it. We good on that? Any other questions? Okay. Going back to the topics. Static analysis. We'll go back to unit testing if we need. Same with the continuous integration. Static analysis. What is static analysis? What is it used for? What is important? Okay. Static analysis is just kind of, I mean, your IDE basically does static analysis. It's just basically taking code before it starts running and looking for common patterns, common mistakes, common issues that may occur. So for example, a pretty easy one is when a method is contracted to say, hey, I don't accept any null values, and yet you give it a null value. A static analysis tool could quite quickly say, hey, you got a problem here, that's not allowed. So like something, here, let me open a new project.
And we did this on the last assignment. We used like PMD. I think.
Yeah. I'll also show I'll show you guys how to mess with Gradle stuff. I will probably dedicate a good chunk of this time towards the end just going over Gradle, as I feel like there's a lot of difficult things with Gradle. Don't mind this. I'm just gonna take a random class. So like if you were to do something like name dot to lowercase, you can see this IntelliJ's built-in static analysis tool says, hey, when you try and invoke to lowercase, it will produce a null pointer exception. This is a pretty simple example of a static analysis. You can also kind of analyze, inspect whole project. And this is another use of static analysis where it'll look at your entire project and try and look for specific type of issues. So sometimes it's an unused declaration, like you never used a method, or maybe the method can be made into void because the return value isn't used. Or you've got redundant variables. Stuff like this. This is basically the reason. These are some of the use cases of an actual static analysis tool. Overall, they're used to make sure that you don't miss simple mistakes, because it's not going to be able to detect whether or not your program will never execute that, or never finish executing. It's only really good at detecting things that it knows are an issue, like vulnerabilities as a result of taking in user input for, I don't know, executing commands or something. Stuff like that. Why is it important? So we don't make stupid mistakes that are easily solvable. It's kind of the plain and simple. And when it should be used, I am kind of the believer that it should always be used, but you can use static analysis, especially when you need assurance that your program has some basic level of security, that you're not overlooking something, that you're not looking past a I don't know. I feel
a lot of teams also make this a part of their pipeline too, so they'll run it and then generate a report on static analysis. So like that's also a big thing. It's just it's used by a lot of different people, and PMD is a big one. That's what my internship uses is PMD.
To touch on that, you'd mentioned like automatically running these reports. For assignment 5, I set up something similar for that. Basically using Gradle, plugins like Jacoco, JUnit, Spotbugs, Checkstyle, and that kind of stuff, and Java docs. I use continuous integration to basically upload those documents, those reports, into GitHub pages so that I can view them without actually having access to the repository. That part's a side bit, but in theory you could also then apply this to PMD, for example. You can have a full-on report of code coverage, what what vulnerabilities are you susceptible to. Here I've got Checkstyle. Checkstyle can be a kind of it's basically static analysis, but for code style. It's just I do have Spotbugs though. Spotbugs is another static analysis, so like it's got warnings about certain usages of classes or methods. The important factor is that I don't need to run the actual program to analyze them. Whereas something like JUnit and unit tests are kind of not static analysis because it requires running the code to test functionality. Any questions on that? I know there's a lot. And we will have a recorded video later in case you want to go back and look at something.
So is static, white box, black box, and unit testing, are those all different, or is there overlap?
Yes. So, well, there is overlap, but static analysis almost entirely, well, it's
Unit tests are normally functional, so you're normally checking against like requirements and how stuff is supposed to work, whereas static is separate from your functional stuff. It's just based like good coding practices and stuff, not based on how it should perform at all.
Yeah, and as far as like white box, black box, it's basically entirely white box. Like you can't run a Jacoco test report on YouTube, right? You can't really get line-to-line coverage on, or like code analysis on something that you don't have the source code to. However, so that it makes it kind of white box by nature. Does that kind of answer your question?
Yeah, that makes sense.
Okay. Any other questions? Okay, I'm gonna move on. The last one not the last one, sorry. The other big one is design patterns. Okay, have an understanding of the different design patterns. What is there? Okay, do you guys know the four major design pattern categories?
Might be good to probably want to go over them just in case.
Okay. As far as what we go over in class, the three main categories, which is based on the Gang of Four, is creational, behavioral, and structural. Creational is a category for at least in Java, for instantiating objects. So it's the category for all the design patterns that help make instantiating objects, not help, but rather categorize that way of making them. What I mean by that is most people are familiar with just creating a constructor. However, when a constructor gets too many arguments, it may be better to add something called a builder pattern, where you basically build the properties associated with a class until, actually, let me just actually show you a builder. Okay. The basic principle is that a class, a builder class, has one required method, which is the build, and it returns an instance of whatever that builder's for. Like, if you have a house builder, it's got to be able to build a house. An example of that is, like, let's say you have some item. That item has a name, a durability, some damage, armor, weight, and value. Stuff like that. Now, if I were to have a constructor with all 6 of these parameters, it gets pretty messy pretty fast. Especially if I want to add new things, because let's say item is used by 100 different classes, and maybe 50 of them create a new instance of it. If I want to add something on, I now have to change 50 classes as a result, which doesn't really scale well. And so the solution to this is by having a builder class. So we've got this item builder that implements builder of type item. So the builder builds items. It will have a copy of its own attributes that mimic this class. I make the constructor take a name. This is not like a thing specific to builder patterns in general. It's just a choice, design choice. You can have this with no arguments and just have a set method for name, but the key idea with a builder is that it always returns itself when you call these methods. So like, whenever I get a new instance of item builder, if I call set durability, I get back the item builder I'm building. So you have a set durability, a set damage, a set armor, a set weight, set value, etc. Then finally we have the build method that builds an item, which hopefully this is visually doesn't look too confusing. Any questions on this so far? And looking at the, looking at the main, this is how you'd use it, and you can kind of see how things are a little bit simplified, where normally maybe you'd make a sword class and a shield class and an armor class, and maybe, I don't know, you have different weights, different values, different damage for each one of them. Some of them don't even have damage, for example. Like a shield doesn't do damage, and a sword doesn't have armor, and armor doesn't do damage, or maybe it does. Entirely it's up to you. This kind of thing, this builder pattern's probably one of the most helpful ones out of the creational design patterns, as you can really reduce the number of dependencies your program has or your classes have. Through a pretty simple structure that's really easy to add on to. Like just as a quick example, long age. I'm going to add an age to the to the item. And there. Now all items can have an age. That was 1, 2, 3, 4, about 5 lines of instruction total. Not counting methods as 3. Pretty simple, and as opposed to having a constructor with all of these parameters in it. Just makes things a little bit easier to maintain. And now I can just go set age. Oh wait, I forgot to make a builder method, didn't I? Alright. Should probably also make it so that the age is printed. There we go. You can see the generic shield is 25H. Anyways. Questions in the builder.
You know she's gonna have us implement one of the design patterns?
She might have, I mean, I don't know, obviously, but I will say that I'm willing to bet that she will have us explain, or maybe explain how to implement them, or some common implementation details about them. So like, what is the difference, or like, how do you actually implement a singleton? What are the characteristics of it? Same with like builder and whatnot. As far as, I think that's builder pretty much in wraps. Singleton. Do you guys know what a singleton is? Or rather, who here wants me to go over singleton?
Probably should just describe them.
Okay. Singleton is pretty simple. You just make sure that there's only ever allowed to be one instance. So like, let's say this main class has more functionality, but we want to make it a singleton. You can basically have a static instance of the main, so instance, and we can make this constructor private. So now no classes are able to call this main constructor. And the only way for them to actually use the main is by doing main.instance, and then they can do whatever they need.
Big thing on singletons is just a private constructor.
Yeah. Private constructor, only one call to that constructor. That everybody kind of references or gains access to. Any other questions on the singleton? Okay. Decorator. Let me quickly pull up the decorator for reference. Okay. Okay, so the decorator is kind of like, let's say you have some interface. In this case, they called it component. And this component has some operation that they do called operation. They then have two they have one implementation of it called concrete component. So let's pretend like this one, I don't know, this operation just says like hello world. So this component, when you call operation, just prints hello world. A decorator can kind of add on to that functionality. So they can take a component and they can then do something in addition. So a pretty hold on. Creational. No, I think it was structural. Yeah. So let's say we have a class. Okay, we made a class hello component that overrides an operation and just prints hello world. We're gonna have a component decorator, which implements component, but it also takes a component. So the idea here is that we can just kind of call component to operation. And then let's say we have, I don't know, goodbye component, or goodbye decorator. We can extend the component decorator. And rather than taking a component, we can just give it a new hello component. And we can override this operation. We can call the previous one, which is just basically going to call hello world, and then we can then print out goodbye world. Okay. You see, oh, there. So you can see when we run the operation for the goodbye decorator, we see both hello world and goodbye world. Now this is a very oversimplification, but I just have questions on this. Okay.
What category does it fall into?
Structural.
For the... Okay.
I have a GitHub repo that I made earlier this afternoon based off of Wikipedia. Like Wikipedia's design pattern stuff.
So
put it in the general chat.
Definition for structural, I put it as it identifies a relationship between classes. Is that like pretty accurate, or?
So structural is how you create the blueprint that creates, or no, how you organize your classes and how those classes are gosh, how do I put this in words? Okay, so we remember creational patterns is more about how we create objects and how we create instances of classes. Structural is kind of how do we fit those into the larger kind of, how do we assemble objects and classes into larger structures? So like basically designing the classes in a way that it fits well with other classes. Rather than being concerned with one specific class only, it's how does this fit in with others? So like a decorator in this case fits in with a component by taking a component and adding on functionality. Whereas a builder, for example, is only responsible for creating a component or item in the example I showed. Does that make sense?
Okay, yeah.
Any follow-up questions or any questions about that?
Wait, so is a decorator like a form of inheritance or something like that?
You use inheritance in order to implement the decorator, and you can kind of see it as a form of inheritance, but basically it's kind of like it will extend, it's going to extend from something, so it uses inheritance for, in this case, the decorator extends from the component, but then anything that extends from that decorator can add on functionality. So like the decorator takes a component and allows you to add additional functionality onto it. So rather than having to extend concrete component, because this may be a final class. If concrete component was final, you would not be able to extend from it. And that's a problem if you're trying to add functionality onto it. So a decorator can allow you to not rely on one specific class per se, but rather take any class of a certain type, in this case that class you can take is the component, and modify its behavior. I think a good example of this would probably be, let's say you wanted to have like I don't know, you wanted to enchant a sword or something. So let's pretend this is an item and this operation is like get damage. Let's pretend this is a sword, and when you call get damage it does 10 or something, returns 10. Assuming you guys can see my mouse. Actually, it might be better if I snipping tool this and draw. It's like, let's say this is damage. I'm gonna shorten that for damage. Let's call this item. This is also going to be damage. And this is going to be your like sword or whatever. This decorator could be our enchantment. I'm going to shorten that for enchant. And so this might take a item and this will just return the result of item dot damage. So I don't know if that's readable. So basically this class in its own does not add functionality, it's just delegating it. So it's basically taking an item and just calling its method. So on its own, this is not doing anything. However, from there, we can have like a sharpness enchant. So we can call this sharp. And then what this one does, it will add on 2 to whatever operation returned. So this is damage. and we'll just say that we just add on 2 to whatever the decorator returns, and return that as the result. Does that kind of make sense? Or you want me to see it implemented? Because I can quickly change what it currently is to reflect that.
No, I think I'm good.
Okay. Okay, next up, adapter. Let me pull up an image of it. Okay, so an adapter, it's similar to the decorator, but rather than adding functionality, you're kind of bridging functionality. Here, let me open this. So here we've got an example of like an example of like a I don't actually like this one as much. It's a little too complicated. So basically, this is also bad. Okay, here. So in this case, I think this is a better example. You basically, the client interacts with a fighter like interface. So this fighter has to be able to attack, defend, and escape. Now, let's say we are working with a library that already has a game implemented. They've got a wizard, and this wizard has a cast destruction spell and a shield and a portal, all of which are things that a fighter may need. But we want to connect this wizard with this fighter, because wizard's part of a different library. It doesn't implement fighter, so we need to kind of adapt their functionality. And so as a result, we make a wizard adapter. This wizard adapter implements the fighter, and maybe it takes in an object or an instance of wizard, and then whenever the wizard adapter is told to attack, it may cast a destruction spell, or when it's told to defend, it'll cast the shield, or when it's told to escape, it'll cast the portal. So in the inheritance way, you basically have a middleman that your adapter class implements a target class, but also holds an adaptee, something that you want to kind of fit to this implementation. Questions on that? Are we all good with that?
Yeah, that makes sense.
Alright. Cool. And then we went over builder, observer pattern. Observer pattern I kind of like. This one's kind of my favorite. Oh, adapter pattern I should probably mention is a structural pattern. Because it changes how it's a way you structure your classes, not how you create them.
So like, if you had item as the top class, and then you wanted to like create sword, could you have an adapter that does that, or does it have to be?
So you have an item interface. So let's say this is not fighter, this is item, right? And you want to have a sword, a shield, and something else? Is that what you're saying?
Like in the last example where you had a sword and then you enchanted it with the designer pattern
Yeah.
or with the decorator.
Yeah.
Then like would you create the sword with a adapter, or like what's the difference there?
So like, can the adapter create an instance of something to kind of adapt it? Or are you trying to say, are you trying to say that like this fighter has a sword now, the adapter now has to account for it? Or can it account for it? Or would you kind of make a sword adapter?
Like, would you use an adapter to create a sword from like a general item class, or would you use the adapter to make like a specific sword? Or like, how does...
It's not that you'd use it to make anything. So because it's a structural pattern, it's not concerned with how objects are created, it's concerned with how they interact. So in this example, wizard adapter isn't concerned with how it gets an instance of wizard. It's just concerned that given a wizard, it needs to adapt it to be a fighter.
Okay.
So the combination of like a creational and structural pattern would result in possibly an adapter maybe calling a factory that creates a new instance of a item, and then that adapter adapts that item to be a fighter, or I guess it's better to just replace item with character, I guess. Better way of explaining that. Does that kind of help?
So,
okay.
I kind of understood it more once I tried to articulate my question too, so that's good.
No worries. Okay. So that's the adapter. The observer. The observer is a very important one because I find that an observer is extremely applicable in a lot of situations and can be adjusted to your situation. Because if you think about it, it's also a behavioral design pattern. The idea behind it is that you have some observable thing, and you can add something that observes its behavior. Does Java actually have their own observer? Oh. Oh, it's deprecated. So let's say, an observer, let's say this is somebody who wants to listen to what happens when a certain event happens. So here. So the observer has a method called update, or on update, that takes an event. So let's pretend like this method is called every time some object updates. And this observable interface allows you to add somebody, or adds the ability to listen when that occurs. You should also be able to remove an observer and notify them of an event. So here, let's see. Character. let's say we have a character who has 100 health, and when they take damage, they are going to notify them. Notify everyone that they've taken damage. A key detail here is that you have a list of observers. I'm just going to make an array list. When they add an observer, you just go list.observers.add. When you remove one, pretty simple. But for listing through them, I recommend copying this list. Let me actually go through this. Whenever you call notify observers, it's going to go through everybody who has basically said, hey, I'd like to listen to when an event happens. And in doing so, during this process, it's possible that somebody might see that a character dies. And they might say, hey, you know what? I'm done listening to this character. The fact that they've died, I no longer need to listen. And so they might remove themselves. And if you don't make a copy of this list before you start iterating, you will run into a concurrent modification exception when you try and remove it during iteration. So I just want to mention that this is an important detail to do. But as you go through this list, you just call on update with the event, and that's kind of like the that part done. Yeah. Okay. So this character also has a take damage method, so that when its health changes, it's going to notify all its observers that the health has changed. So what does this actually look like? Well, we can create a new character, Bob, and we can say, hey Bob, I'd like to listen to when you have an event. Bob received event, or observer. Let's call this observer 1, observer 2, and we go bob.take damage. Yeah, nothing too complex here, but I do want to mention that this is extremely present in memoranda, or not even memoranda, in like UI elements. Whether you're working in JavaScript, whether you're working in Java, if you're working with any front-end elements, you are most likely working with some kind of event system or observer pattern, because in parallel processing environments, it is not ideal to kind of always have everything on the same thread. You kind of want to have a thread for the UI and have a thread for large computationally difficult tasks. Well, anyways, I'm getting on the side tangent. Let me just kind of demonstrate. As you can see, observers. Questions on observers.
Yeah, what's the textbook definition behind them?
Here.
Because I think I have it as it communicates between different classes. It's a way of communicating between different classes.
Wait. What was, you want to run that by me again?
It's for the definition behind behavioral. It's a way for classes to communicate with one another, like the way it's structured, or...
Oh, behavioral specifically. Yes.
Yeah, yeah.
Yeah. Behavioral is how classes communicate and interact with each other. Observer is a design pattern within that that makes it easy to communicate when certain events, literally events, anything that happens, it could be creating something, destroying something, updating something, changing something, whatever. When events occur, you can do some functionality. But yeah, behavioral, basically how classes interact with each other. A little bit different than structural, because structural is more reliant on how things fit together, not necessarily how they communicate. And typically you want to use an observer pattern when there's like basically one-to-many relationships with objects. So like if a classic example actually, if you are on GitHub and let's say you are looking at your GitHub repository, and let's say there is a change that is made. Like somebody pushes a change to the GitHub. If you've ever seen that, there's typically like a little banner that'll pop up below this, below the code section above this little black bar. And the way that happens is basically when you go to this page, you are telling GitHub, hey, I'd like to listen to when commits are made to this branch. So like basically I want you to notify me when changes are made. And so when that change occurs, it then notifies your browser that, hey, a change has been made, and then you display that at the top. Same thing happens in PRs, like when you're browsing the changes of a PR and somebody changes the branch you're viewing, it'll say, hey, this is out of date, you should update. You should refresh so you can see the most current version. You'll see it everywhere once you start being able to identify what that looks like. Questions regarding observers? Okay. Factories. Anybody know what the factory is part of?
Structural?
Not structural. You'd think structural because the factory kind of you build stuff, but
Is it creational?
yeah, it's creational. So a factory is kind of like, it's basically I'm not going to use the word facade because the facade is an actual thing. It is kind of the middleman between creating an object and requesting an object. So like, as a client, I may need, well, let me think of an example that's good. I think I actually have one here. Okay, here's one. Let's say I am creating a character in a game, and I want to be able to have different, I don't know, races, and different like elves, dwarves, humans, orcs, etc. I might want to have a factory to, given the race of the kind of the character that I'm making, I would like to have an instance of that character. So, for example, a dwarf factory will create a character, and the dwarf factory will just return a dwarf. Or an elf factory will return an elf. This example I'm showing you here is more of an abstract factory, but typically within a factory you may have some kind of switch case, or some kind of choice between which one. For example here, this abstract character factory is technically a factory in its own. It's just a factory that produces factories. Which is definitely not confusing at all. It's the factory. But in theory, you basically, the end user, the person relying on this class, does not need to know what things are supported. Like they kind of do, like they kind of need to know, like, hey, if a human's supported or not, but like they don't need to know what class specifically they are getting in return. They just need to know that it extends from a specific class. So if you have a character factory, all you need to know is that you are returned a character. You don't need to know if it's an elf, if it's an orc, if it's a dwarf, if it's a human, stuff like that. Questions on this? Are we good on factories? I'm gonna take the silence as a yes. Hopefully. Okay. Next thing is a composite. Do you guys know what a composite is?
Nope.
Okay. A composite is basically something where it's a tree-like structure, usually. The idea is that you have a class that kind of combines or groups together classes of the same type. So, let me see if I can find a good...
And it's structural, right? Or
composite is... Yes, structural. Okay. Here's an example of a composite. The idea is that, let's say you have some interface. So in other examples, it could be, I think the example that she likes to use is a school or department, but ideally is that you have some component, some interface that then is extended in either two ways. One way is you have a leaf. So this is something that just directly implements this interface as a singular thing on its own. And then you have a composite, which is a collection of these components. So, this composite could be, if let's say this leaf node, let's say this leaf is a class. No, class is a bad term when you're dealing with programming. Let's say this is like a finances department. So let's say a leaf node is it's either finances or it's going to be education department. It's going to be HR. Like all of these are examples of leaves. A composite may be that like ASU is a composite where it has multiple education departments. It has maybe one HR. It has a legal department. It combines all of these departments while also being a department in itself. If that kind of makes sense. I think a good example of a composite is back on that item example where, let's say you have, this is an item. An item you can do like, well, hold up. I'm trying to think out this example in my head, and I think it's falling apart with an item. Anyone else got a suggestion? while I try and find one. Oh, here's one. An example is like a file system. You have either a file or a folder. Both of these are like a file component. So like Java technically does this already, where like anytime you have a file object, a file doesn't just represent a like text document or Word document. It can represent both a folder and a document of some kind. And so both of those have a name, both of them have a size, both of them have the ability to be kind of created, and you should be able to like print it out what's in it. And so in the leaf of a composite is a physical like document. So the document will have its own name, maybe a file extension, and maybe how large it is. And then a folder also has a name, but its size is the sum of all of the folders or files and folders within it. So it's like a tree, like a recursive tree in that regard. So you can add a folder to a folder, you can add a file to a folder. Both of those will add on to the actual size of that folder. Does that kind of make sense? Very lively. Have I put all of you to sleep?
No, I think we're good.
No, that makes sense. Sorry, I'm just I'm also writing my my cheat sheet right now, so yeah.
No worries.
Same.
I can't remember, was Melhaze allowing collaborative cheat sheet, or was that just 335?
I think that was just 335.
Okay.
I mean, I don't know. I don't know. I can.
I think it has to be handwritten.
Yeah.
Okay.
So it'd be hard to collaborate if it's handwritten. So.
Yeah. Fair enough. Okay. Well, just to clarify, does everyone feel confident that they could explain a component on a test, or implement it? Not implement it, maybe like explain it.
No.
No? Why is that?
I don't know. I didn't even know we were allowed to have a cheat sheet until you just told me.
Fair enough.
That make me screwed.
It may help the fact that this is recording, so you can go back through it and you can write down whatever notes you need. So.
Fair enough.
I think just focusing on like one of the design patterns on each of them. I think that's all that really she cares about, right?
Yeah, she might. I mean, she explicitly put these on here, have a basic understanding of these, and I have a feeling that you want to have these written down and what the difference is. Like, have an understanding of these at the very least. You don't really need to understand too many of the other ones, but these you should have you should be confident enough that you can make something extremely simple that implements these. Because
did we go over strategy?
We have not gotten to strategy yet. We've just going over composite. We still have abstract factory and strategy.
Okay.
And state. I actually did touch on an abstract factory before. It's quite literally just a factory that produces factories. So to quickly show the kind of the implementation I did here, I have a character, which there's 4 characters that extend from this. So an elf, a dwarf, an orc, and a human. And then I have an abstract character factory. So basically an abstract factory for creating characters. As I explained, like I want to have different races, and therefore each race needs to be created in a different way. And as such, I need to get the specific character factory given a race. So, in here, get a character factory, basically given whatever they give us, whether it's a string that's human, elf, orc, or dwarf, we'll create a new human factory or a new elf factory. That factory is pretty simple, just creates the character given the name. And the actual implementation side of that just looks like something like this. Right, create a dwarf factory, create a human, an elf, an orc factory. Then we can create a dwarf named Bob and a human named Joe, an elf named Steve, and an orc named Jeff. As you can tell, I have amazing naming schemes and definitely do not run out of names very quickly. Sarcasm is definitely hard to convey. Abstract factory. Here we go. You can see this. I should probably mention that character has this method called introduce by default. It says, hello, my name is get name. I am a get race. So in here you can see, hello, my name is Bob, I'm a dwarf. Hello, my name is Joe, I am a human. Hello, my name is Steve, I'm an elf. And if we just look at some of these implementations, they're pretty straightforward. But you can imagine this could be applied to like a character creation screen. Like if you choose your race, you're going to create a factory for that race, which will then maybe add a bunch of fields to the UI saying like, okay, give me, it's going to have these attack stats, it's going to have these defense, it's going to have this look to it, like it's going to basically be used to create that character. As maybe there's some things that are only attributes of orcs, or some things that are only attributes of elves. So having a factory that returns another factory, you can control what is required to actually create the character or the thing. So you can kind of change the requirements based on what type of factory you need. That makes sense.
Yes, that makes sense.
Okay. Moving on to strategy. Let me pull up a diagram for it. This is a pretty simple one. Basically, a strategy is kind of like just it's a should probably clarify what type it is. I believe it is a behavioral. Yeah, it's a behavioral where the you have an interface that defines what functionality you want, and then you have multiple implementations of that do that functionality a little bit differently. So in this example, the strategy is just basically math operators, and implementations of that are the add operator, the subtract operator, the multiply operator. Each one of those return an int, and they are performed using do operation. However, each one of them does that operation in a different way. I think a good example of this might be you probably do like a attack order for a character. So for example, you might have one strategy where player 1 attacks first, and then like the like passive entities attack after, or not passive, the enemies attack after. Or then you may have another strategy for attack last, where like the player attacks last after the enemies have attacked first. And you might need to be able to switch those out depending on what type of zone they're in, or based on the speed of the enemies, or if the enemy is a boss, things like that. It's extremely applicable. You can also use strategies paired with factories. So like you could have a strategy factory for math operators. So I think I'll do a quick example of like so given some, or provide an int given two integers, a and b. So one implementation of that may be addition. Implements math operation. This just returns a and b. And then subtraction. And then maybe you'd have like a, I don't know, a math operation factory. You can then have a method called like public static math operation, get operation, and then you can basically say, okay, if they said add, if they said subtract or multiply, that's what they return. And so adding a little bit of user input, you can do math operation add equals math operation factory dot get operation add. Kind of see how this operates. Okay, it is behavioral. Questions regarding the behavioral pattern. Or not behavioral, sorry, strategy.
Nope, I think we're all good.
Awesome. Okay. And finally, the state. Does anybody need me to go over the state design pattern?
Yes, probably. Probably a good idea.
The state is honestly, it's pretty identical to the actual
Singleton?
not singleton, the strategy.
Oh.
So
What's the difference?
here, I believe the difference is the actual use case. This is the state. Yeah, if I actually put the state and strategy side by side, they're pretty similar. I'm pretty sure the state is more so for there's a fixed number of states that a class can be in. So for example, if you're making like a robot and like a maze navigating robot, you may need a state for like being idle, and a state for moving, and a state for turning, and a state for kind of determining its location, things like that. Whereas a strategy is more of like, how am I gonna approach this? It's not so much of like, we are currently doing this now, or this is how we currently handle things. It's more so of, how should I perform this operation? So, a better example is like a strategy is something, maybe you want to sort something, you may provide a specific strategy to sort that, that data. Whereas a state is more of like a fundamental thing you design into your program. So you design your robot to have, I don't know, 6 states, and it switches between those states. However, it's not a case of like, okay, how should it round this corner? It may use a strategy for turning, but it's not necessarily, the state is not a strategy. It is a kind of, well, it's hard to explain a state without literally explaining the definition of state in general. I don't know if that kind of explained it a little bit, kind of the difference, or are you still confused? Any questions about the state, or are we good on that?
I think we're good on that.
Okay. And just to clarify, a state is also behavioral. Okay. Let's see. Okay, so are we good on design patterns overall?
I think so, yeah.
I want to mention that there is one other category that we did not go over in this class that's not in the book or the Gang of Four, and that's called concurrent. And concurrent design patterns are useful for actually designing systems so that they're able to work in like a multi-threaded environment. I have a list that I grabbed off of the Wikipedia, but you have things like active object, bulking, binding properties, compute kernel, CPU atomic operations, joining, locking, messaging, monitor object. There's a bunch of these. These are definitely, these are definitely worth looking into in free time, but it's just not related to this, this final. From what I've seen, a lot of the professors haven't ever talked on the concurrent design patterns. They've only been focused on the Gang of Four. But yeah. Okay.
I was wondering where the 4th one was.
Yeah. It's, I don't know. I think that they just kind of they're stuck with the Gang of Four, and they just don't want to branch out from there, just to keep things simpler. Because concurrent patterns can get pretty confusing. Okay. The next thing, oh yeah.
Can we go over the continuous integration?
Yeah. Let's go over continuous integration. let's see if she has any good slides on it. If not, I'll just briefly pull up something.
Yeah, continuous integration is also part of like the delivery part, right? CI/CD.
Yeah.
I remember one of the guest speakers talked about that.
Yeah. So continuous integration. What was that?
Oh, no, you were saying.
I was saying the continuous integration is kind of a term that encapsulates the idea that all the multiple developers can kind of continuously add their changes or implement changes to some code base without having, like, in parallel, and kind of having a pipeline for those changes to be made and put into effect. So like you can continuously implement things into your project, and there are things that help, there's tools that help this process. Things like unit tests that you can kind of run autonomously is a key part of that. Let me see if I can find one specific repository.
Yeah, and GitHub action has something to do with the integration part, right? Or
yes. So I'm going to take this repository's examples. This is, for context, this is just a JavaScript interpreter for Java. So like basically everything here is written in Java. It's meant to read JavaScript files and as a result run them as Java code. So in order to make sure that these in order to make your own interpreter, you got to make sure that you're testing a lot of things. So you want to test that you're not breaking features when you make changes. And so as a result, you kind of want to say, hey, when I upload a change, I want you to run a set of tests. And GitHub Actions is part of the service GitHub that allows you to define how to kind of test and verify that your changes were valid. So I'm showing you a build.yml file. Typically GitHub Actions are, in order for them to actually be added to your project, you need to add this build file or a file with this name in this directory to your project. So .github workflows build.yml. This file will be read on GitHub's end, and then they will kind of parse it for information. First thing is they're going to name what kind of action it is. This one is Java continuous integration or Java client. I'm not entirely sure what their abbreviations they use. The second thing is that they have a trigger. So like trigger this action on the following kind of events. So the next thing is, so trigger it on either a push to the branch containing main. So when a commit is pushed to the main branch, I want you to run the set of jobs defined later. Alternatively, whenever there's a workflow dispatch, alright, this is a little more specific to GitHub Actions. I won't completely go into detail of how this works. Just basically know that this is a, like, don't publish these, don't run when this thing is present, from what I understand. The key thing here is that you can basically trigger a set of jobs when some event happens. This is not limited to pushing to a Git repo. This could be when you when somebody makes a new pull request. This could be when somebody creates a new issue. Now, those are just the triggers. what are the actual jobs that can be done? The general idea is that you can spin up a virtual server, so you can probably think of this like a Docker container of a specific virtual machine. So in this case, the job is to build, this is the name of the job, build, and this build job runs on a virtual instance of Ubuntu that's at its latest version. And then it has a condition saying if the commit message has this text in it, do not run the job. So basically it cannot contain the CI skip in the commit message in order to run this job. Now, the steps in order to actually execute this job starts out with using a specific action. So it's going to start out by using this checkout action. So you can imagine you have this Ubuntu latest virtual machine. It's a blank Ubuntu instance with as minimal software on it as possible. You basically are, by having this action called checkout v2, you're saying, hey, I want you to check out this code base, this repository, using the second version of this action, and then I want you to fetch the last 30 commits. So you can see fetch depth of 30. Next, well actually, this is basically gonna do what is essentially that git pull that I did earlier, this git checkout, where I basically loaded all of the contents of a specific GitHub repository into a folder. The next thing that we have it do is we say, hey, I want you to set up the JDK number 17. This is just the name for this action. This has nothing to do with actually executing anything. This uses keyword specifies what action to run. And you can see setup-java version 2. These kind of actions you can find through just Googling. Some of these are open source. You can browse them. Typically this area here is where you'd find them if you haven't already added them. Like if I go to here, if I go to actions, you'll see a bunch of different actions. So like I could see Java with Gradle. Configure that, and you'd see a very similar thing where you've got checkout v3, setup Java v3, similar thing. Now going back to the previous build I was going through. Inside of this setup Java action, we want to specify a few things. So we want to run this action with a bit of information. The first thing is that this action can have a distributor. So basically who actually distributes this Java JDK, and then what version of that JDK do we want to use? In this case it's 17. So Temurin 17, go Java Temurin 17. You can find the releases, I believe that must be Eclipse's JDK. But there. So now at this point we have told the virtual Ubuntu machine to check out the repository and set up Java 17. The next thing is they have it validate the Gradle wrapper. So they are using this action, a Gradle action that's called wrapper validation action. So this basically will make sure that the wrapper is the right version for this Java version. This is also something you can Google in order to like figure out how this actually works, and like just search Java or GitHub Actions Gradle validate Gradle wrapper. You'll find something, or you'll find the actual GitHub for this. This step isn't really necessary for what we need, but it's nice to know that your wrapper is up to date or is using the right version. The next step is building and like running it. In this example, they're using a Gradle action to actually execute and build and publish the results. However, there are other ways of doing this. You could basically have the virtual machine run a command instead. I think I actually have an example of an alternative way of doing this. Yes. So here I basically do the Gradle build action. I set it up, and then I modify the gradlu file to be an executable file. You don't have to worry about this task, it's just custom. And then I basically have it, hey, I want you to run, so execute a command on this virtual machine, and that command is going to be gradlu build test. I want you to run it in parallel, and I want you to cache the build folder. So this build command will make sure that Gradle has built its latest version, and the second one will run the test task on the actual Gradle. It'll run the unit tests, and then I was playing around with trying to be able to upload the results of it, but that's something I was never able to finish fully. But why is this useful? Well, here's an example of where you can run these automated tests, and where is it? Oh, I think this actually doesn't show it. Okay, so here you can kind of run automated where is it? Here. You can actually see the output of what I ran, the build and test method. So you can see it's I had spot bugs run, and then I had spot bugs test run. I had spot bugs main run. I had the test method run. I had Jacoco's test report run, generate Javadoc run. All of these happen automatically when I made a commit to my GitHub, or when I pushed my commit to GitHub. Why is this helpful? Well, you can basically tell GitHub, once it's done running these checks, if all of them passed, I want you to merge this branch into master. Or I want you to merge those changes into a dev branch. And then I want you to run a second set of tests. I want you to spin up a machine where this server will run on. So let's say we have like a web server. I want you to spin up a web server with the most latest commit on it, and then I want you to run a bunch of network tests. I want you to try and test all of the protocols, all the website endpoints for that server, and if all of those passed, we can safely say that it is ready for production and automatically merge it into production. So going from having to commit your code, push it, create a pull request, merge it into test or dev branch, start up a server with the test version on it, having to run your own test, make sure that it's all right. Once that's ready, merging that into master. Rather than having to do all that manually, you can have a great or an action workflow that automatically does that stuff for you. Not only that, it can tell you exactly, hey, this test failed, or this it failed on 3 different accounts, or you had this percentage code coverage. It's a way of automating your workflow so that you can take as much human labor out of the testing process as possible without sacrificing security, obviously. Yeah. I know that was a lot, so questions on that and that process? And again, everything here is recorded, so you can go back and look at it later.
No, I feel like you explained a lot. I feel a lot more confident with this now. Thank you.
Okay, glad to hear it. The best way I like to think of actions is just like it's a text document that explains how to launch a virtual machine to do whatever tasks you need for your GitHub. It's like the plain and simple. It doesn't need to build your code, it can just increase a single number in a file and then push it to GitHub. It's as simple as it can get. You could also just print hello world. One of the nice things I do like about it is that you can actually host, like if you notice, sorry for the blinding bright light, but this website is under github.io. I do not own this domain. I did not pay money for this domain. Anybody can go to this URL, and that's because GitHub Actions is set up in a way that every time I make a change to my code, if I change a certain folder called the my docs folder, DOCS, which I'll show you right here. Yeah, so every time this folder is changed, GitHub Actions will be fired up, or GitHub Pages will be fired up, and you'll see this Pages build and deployment. So every time I make changes here, it will build them and deploy them to this URL so that it has the most up-to-date version. So the benefit of this is I can work on a bunch of changes, I can add documentation, I can change my code. I then just have to build it, commit those documentation files, the reports, and then GitHub will take care of the rest so that this website is up to date with the most recent version. I don't have to touch the server backend. It's great for like documentation and things like that that heavily rely on being able to stay up to date with the most recent version of code. Stuff that can be a little bit tedious to host on your own or costly. So, highly recommend looking into GitHub Pages if you are interested in hosting your own documentation and stuff like that. But it's an example of this continuous integration, and you'll most likely see that in a lot of open source GitHub projects that you come across, where they'll have some form of automated workflow. Okay. We've covered GitHub, we've covered continuous integration for the most part. Covered a bit of Agile and Scrum. We talked about static analysis, design patterns. Are you guys familiar with, or what else do you guys want to talk about?
What were metrics and measures again?
Metrics and measures?
Yeah, I don't remember those.
It's not on the exam, so okay. Basically, they're just kind of like, they're how you measure, well, it's literally how you measure things. they're just kind of they're different tools you can use to analyze your code. So one of them we've used before in previous classes, lines of code. For example, I have this tool built on IntelliJ called Statistic, and I can basically look at a project or a class, and I can say, hey, refresh on selection, and it'll tell me, okay, you have 12 classes in this folder. In total, you have 228 lines of code. 166 of those are actual source code, which is about 73% of it, and 8% of them are comments, which is about 4%, and blank lines are about 54, which is about 24%. So this is an example of measuring the amount of, just measuring effort. So I can see what percentage of my code is commented, because typically you're probably going to want to have at least, well, I'm not going to give a measurement for like the amount of comments, but typically you want to have things commented, and if you only have 4% comments, and if you see 0% in certain classes, you can pretty easily tell, hey, there's no comments in that class. This is a pretty primitive form of metric, but you can usually tell how complex something is. Like if a class has over 1,000 lines of source code, it's probably doing too much. It can probably delegate some of that complexity elsewhere. However, that's not necessarily something you know for a fact, it's just something you can kind of gauge and guess. Cyclomatic complexity, I believe, hold on, let me double check this. I think cyclomatic's complexity is kind of how many times you can branch back to itself. Like, so a lot of these are, here. It's a mathematical term, but like, you can kind of guess, like, if each one of these is, this is bad on this. Here's one. This is a control flow one. You kind of see that like these 11 lines of code have a lot of complexity to them. Not only is there a while loop that can kind of loop back and forth, you also have if statements that can switch the paths of your actual program. Then you have switch cases, like, well, I don't think this is necessarily bad, but there's some complexity here. It's basically when your code starts branching and connecting in weird places or connecting back in a lot of strange ways. This is a good one, of like a confusing one. Like, trying to follow this visually already just is a little confusing on how you get from the start to the end in terms of like what D will be at any point. Like, this kind of makes your program a little more complex because you're constantly changing the condition at which you keep operating or do a specific operation. I don't know if that makes any sense. It's basically just how complex it is cyclically. Which is just repeating the same definition back, but I don't know.
Yeah, okay. Yeah, I get that.
It's definitely important to measure software so you can tell if you're in a habit of designating too many responsibilities to one thing. But yeah. Any questions on the measures and metrics? Okay. You guys know what refactoring is?
I
So,
mean,
like,
I
measure-
no, sorry, you can go.
Isn't it like a way of just seeing coding practices or following coding practices? Or am I thinking of something else, of code review?
You're thinking of code review.
Okay, never mind.
This is more of a reinforcing those. Chase, do you have something?
I was actually just kind of like about to say like that as well. Just like basically like the code reviews are like finding those like code smells, and then refactoring is like implementing like fixes to those code smells in the program.
Exactly. I'm sure everybody has, or yeah, we're all in 368. Yeah. So everyone here has worked with memoranda. You know what bad code smells like. Refactoring is the process of kind of changing the code without changing the functionality in the direction that reduces the complexity and reduces the difficulty to actually operate within that code. I can I don't know if I can pull it up. Hold on. I'll pull up one class from our project just because I know I can kind of give the best example there. Okay. So I pulled up an example from memoranda. And I kind of just wanted to explain like kind of how you can refactor things without changing functionality, because there's kind of things in here that kind of smell that really shouldn't. Like some of the an easy example is just some of these names, and also the kind of, for example, refactoring is literally just making things easier to read. So you can do things like property key. Oh, I should probably explain what I just did. In IntelliJ, you can right click. There's this little refactor option, which has a lot of really useful tools, and I highly recommend getting acquainted with some of these. Refactor is the most amazing thing in here, the rename, because let's say you use a variable or a class or a method or a field a million times. If you just use this rename, you are going to edit all usages of it. As you can see, I don't need to change every single instance of it, and as a result, it makes changing things so much easier and less confusing. Another thing is kind of there are some tactics you can use called well, this is a bad example for this, but there are some ways of refactoring that are really useful. So it's a video that I posted earlier in this week called a never nester, somebody who doesn't nest more than 3 times. What that means is like every time you have these opening curly brackets, you can imagine that's +1 to this this indentation. You can visually see that as well. So like this is 1, this is 2. If you need more than 3 levels of indentation, you should be able to rewrite what you currently have to no longer need your code is basically starting to smell. Like having more than 3 indentation levels is making your code smell. And like a kind of I don't know, all even numbers. I'm gonna give an example of like so if you needed to do like 4, like this is something that doesn't smell too bad, but if you start going like if I is greater than 10, sorry. Okay. This is kind of like approaching like 3 levels of indentation is a little bit much. There's a technique you can use called inversion to try and make this a little bit more readable. So let's say you want to do something when a certain condition is true, but ignore all other cases. So like, notice how we don't do anything if I is not even here. The simplest way to reduce the amount of indentation you have is to kind of create this thing called a safe zone. So you say, hey, if I is not even, we're just going to continue. We're going to skip. And then now we've created a safe zone past this if statement that we know for a fact I has to be even. And as a result, we also reduce the amount of kind of code smell by reducing the amount of indentation we use. So it's this is one of the things that I find is super helpful for like, let's say you're validating passwords, for example, which you should probably never do in like plain text. Yeah, there's stuff for that, but anyways, let's say you are. So you have a username and you've got a password. By using this kind of inversion technique, you can do this kind of chain of if checks where like if the length is less than 8, don't continue. If the hold on. Let me write this poorly and then I'll write it good. So like if the it's greater than or equal to 8, if the password, let's just make a if auth dot contains key username, if auth contains or auth get username, like take something like this for example. You'd even have stuff like if password or if stuff like this gets really messy, right? especially when you start doing stuff like this. So this is an example of something that has like a code smell to it. It's pretty difficult to actually read. It starts to get more complex as you add more rules, and overall it just isn't that intuitive to follow along with. Whereas we can do some simple techniques to kind of fix this by doing things such as inverting conditions so that we create these safe spaces. So as we saw earlier, it's just swapping this to be if it's less than 8, we return false. And then now we can reduce the indentation and kind of make it easier to read through that. We should probably also have an if statement for if the password is null. And also if the username is null. And that way we can remove this. And then we can also do if auth does not contain the username. Then we can return false. And then here we can kind of just reduce this down to kind of reducing each indentation level down to a single if statement to reduce the overall complexity. And kind of creating this safe space where, like, at this point we know that the password is not null. At this point we know the username is not null and the password is not null. At this point we know the password length is greater than or equal to 8. At this point we know that we have a password that matches that username. And so all we have left is to compare the password that we have already to the password we were provided. Questions on that? On this like never nesting topic? Any last questions before I wrap things up?
Oh, should be good.
Okay. Well then, I'm going to stop recording.